Hello, this is Sarah Coffin, and here's my homework 5. So, as you can see here, we've got the homework 5 sim maze set up, and I've just reoriented the camera so that you can see it as it traverses. And over here, we're going to run the brain code. Alright, so we start it up, and it immediately goes into a wall follow. So the strategy for this is a state machine with wall following as part of its component. So it utilizes the fact that there are hallways and doors. It wall follows along the most northerly side of the hallway, given its current going direction, when it's in the forward program mode. You can see over here, program mode is 1. All of these numbers, like you see the state number here, correspond to defined values within the code, to make it a little bit more organized. So as you can see on the corner here, it just detected that there was a doorway, and now it's proceeding to move to the middle of that doorway and then turn down it. So I will talk more about the state machine in a little bit, but first I want to talk about some of the things that allow a lot of its motion currently. So first of all, it takes the position t or position theta value from the robot .hh, the header file, and it maps that to north, east, south, west, and then northeast, northwest, southwest, southeast values. These are not like equally distributed ranges. The north, south, east, and west are each about an eighth of pi wide ranges, if that makes sense. And then the northeast, northwest, those intermediate directions have a little bit more space. So yeah, and that's to give it a little bit of a more defined position. And since there's given some error with that value, supposedly from class, that's what I heard. So that handles that because it's a wide enough degree angle that should be that. And that allows us to do turn right and turn left functionality. So instead of deciding, oh, turn this many degrees or something, or this many radians, you say, make sure that you're turning to the west, or make sure you're turning to the south. Another thing that I just want to go over as it's rounding this corner is just the way that it interacts with corners. So it'll go up, around, and then it'll turn back. So this is to equalize the number of left and right turns that it makes. So yeah. Additionally, it's tracking the distance northward, so every time it passes through one of these hallway or doorway traversals, which is what it's called when what it's doing right now. So right now it's doing a traversal through a doorway, and because we only care about moving in the northerly direction when we're going in the forward program mode, it just kind of passes by until it hits a value directly in front of its face. And it does this because it knows it's moving north. And then it's allowing it to add to this total distance value. And this total distance value is a rough estimate for about approximately how far it's gone in the forward direction. It does a little spin. So it detects the doorways by using a wall buffer, which is a 10 integer array with 1s and 0s, 1s if there's a wall, and 0s if there's no wall, and it auto updates with every callback. And basically once it reaches more than 6 zeros, it says there's a doorway there, and that's what that little wiggle sometimes does, is just filling up that buffer and waiting for it to go to the correct amount. And then it begins the traversal. There are 2 separate traversals for when it's coming off of a right side wall follow, or when it's coming off of a left side wall follow. Here, you may think it might be more efficient to go the other way, but to keep it consistent with the right-left turns, it actually goes this way. And that's not a bad thing because there is a reverse program mode for handling walking back. That one is more simple because it assumes that you're already on the 12th row and you only have to go back one. So it just, at the very end, it will flip which side of the hallway you're wall following on and then just do a slightly larger wall follow in order to actually hit the goal. It remains doing the close wall follow on the forward program mode because it's slightly more efficient and it has less issues with the wall buffer. So yeah, so it uses the wall buffer and the cardinal direction thing in order to point itself and detect when there's doorways. The actual state machine has a couple different states, and then some of those states have subtasks. There's also a validate thing that runs at the very beginning before any of the states, and this is doing checks for, this is how it checks if there's a doorway or if there's a doorway and it needs to do a turn correction. I don't know if you've noticed over here in the print statements, but there's been things like turn correction to 6 or turn correction to 2. And that's when it needs to, or that's when the wall follow kind of messes up a little bit. Well, it doesn't mess up, but it hits a dead end. Like right here, you'll see that it's headed towards a dead end. How it does that, how it handles that, is it does a little bit of a wall follow, and then it will get pointed away from west, so it will want to correct itself. So if we look over here, we wait for the turn correction to 6. That's the west direction. And so it does its turn correction, and once it notes that the range is less than the accepted value, it says, oh no, I should be going the other way, and it does a turn correction towards east. And so that's how it flips around when it's doing the wall follow. So when it encounters an error, it just says, okay, let's switch to the other side wall following. So I stay along the current edge, but I look for the doorway along the current edge. And so this stops it from having to go all the way back around like a full wall follow. And it keeps it moving in a northerly direction. It's going a little bit slow because it is really running at velocities of 2 and -2. And also the real-time factors at about 0.7. But in terms of actual efficiency, I think that this is pretty good. It doesn't end up going through a lot of the maze. It ends up just moving as forward towards north as it can, while keeping the equal number, or a roughly equal number of right and left turns to stay in the middle of the map. Now, yeah, I'll just keep going. Here you're going to see the turn thing affected. So this is where it's trying to equalize the number of turns. So it came out from this way, came over here, and it turns back. But it's going to hit the wall and be like, okay, can't go this way. Turn around and go back the other way. And again, that's just to try and equalize the number of left and right turns so that you're kind of trying to stay towards the middle of the map. And then it does its one little spin, and then it knows that it needs to go the other way. So as for the state numbers, 47 and 48 are the two different wall follows. 49 and 50 are the two different door traversals. So right now it's doing a door traversal. The state subtext value is just for tracking what subtask it's in within some of the states that have nested ones. So the door traversals both have nested state machines. The actual wall follows don't, they just have a function that runs. And then the turn right and left functions are included within those nested state machines. And so really how it all works is the states are kept tracked and the state subtasks are kept track within global variables because it runs each iteration of the callback. There is no actual sitting in a function and looping. It all is handled through these state flags. All right, and as you can see, we're nearing the end. We've hit row 11, but obviously we can't get to the goal yet, so it's going to have to switch program modes. So right now we're in program mode 1. Once we reach an approximate distance north greater than the 11th row, it will switch to program mode 2, but only once it's on a wall follow. So yeah, it doesn't, in the middle of a door thing, do any sort of that. The thought was that the wall follow along each of the hallway edges would be considered almost like a ready state, because when it's in that state, it's checking for when the doorways are, and it's checking for when it's at the right value and whatnot. So right now it's doing its final turn to complete its setting up into a wall follow along the right side of the hallway. And you can see over here that it just switched to program mode 2 because it noticed, oh hey, I must be in the 12th row because I've traversed a lot to the north. And I know those words mean are a little wonky, but that's because 0 is in this direction. So I just decided to call that north. And the map is technically on its side. So there, it just switched sides because it noticed that it was in program mode 2. So now it's on the other side. So you notice how when it was going through forward, it was always on the furthest inside edge of each of the hallways. And now it's doing the same thing on this side. Except it knows that it only needs to go over one more doorway, theoretically. So it's going to get to the doorway, proceed through the doorway, and then proceed into a wall follow, because it knows the goal must be on the other side if it didn't run into it yet. Because we know the goal is in the middle of the map, or in the middle of the maze, not on the edges. So you see here, it completes its turn, and it drops into its wall follow. And if we look over here, we'll see that it meets the goal and the robot gets just right. Alright, see? I reached the goal and the robot was just right. Well, thank you for watching, and I hope you enjoyed. Bye now.